Hi everybody, this is a video for my Intro Calc students. We're going to start off here by looking at Desmos. What we're going to talk about today is we're going to talk about non-function curves. Everybody remembers that y equals x squared, a parabola, looks like that. Nothing too terribly fancy about that. You've been doing enough of these since grade 11 a gag a goat. And you do realize that that is also a function, right? I could, of course, instead of calling that y equals x squared, I could have called it the function of x is x squared, and it's the same graph exactly. What we mean by that, of course, is that it's a function in the sense that it is one-to-one. For every x value, there is, of course, only one y value. I think of functions like a machine or a rule. I put in an input, and it does something to my input, and it gives me an output. In that sense, what I like to tell my grade 10s when I introduce the very idea of function is I tell my grade 10s that a function's like a toaster. If you put in bread, out comes toast. Every time you put in bread, out comes toast. Imagine what a toaster would be like if you put in bread and out comes toast. Or maybe the next time you put in bread, out comes a Pop-Tart. Maybe the next time you put in bread, out comes a bagel. Quite the magical machine you've got there, but I wouldn't call it a toaster, and I certainly wouldn't call it a function. If I put in x is 1, I will get x is 2 every single time. Sorry, let me say that again. If I put in x is 1, I will get y is 1 every single time. If I put in x is 2, I will get y is 4 every single time. It doesn't bother me that there's two different x's I can put in that'll give me 4, both positive and negative 2, because functions are fine that way. Two different inputs can have the same output, but you can't get two different outputs from the same input. We can summarize that with something called the vertical line test. Any vertical line you draw will only cut through a parabola once. Now, parabolas are y equals x squared. What if I drew x equals y squared? Well, as some of you have probably already seen, that's a sideways parabola. And that's definitely not a function. It fails the vertical line test. When I plug in x is 2, I could get either the positive or negative square root of 2. When I plug in 4, I could get either plus or minus 2. So that's not a function. Of course, I could make it a function. I could make it really two functions. I could say it's f of x, which is the square root of x. There's the black part. And it's g of x, which is the negative square root of x, which is this burgundy part. And together, those two things make up the function, or make up a graph that I would call x equals y squared. Individually, each of them are functions. So sometimes if I have an equation that isn't a function, I can turn it into maybe a combination of functions. Or maybe I could even do something like, and let me just get to a page I can write on here. If I had something like, x equals y squared, and I didn't want the squared on the y, I could say, fine, y is equal to plus or minus the square root of x. So it's, for a lot of functions, it's not a big deal if the y is squared instead of the x. But they can get more complicated than that. For example, here is a circle. A lot of people didn't know that when you square x and square y, you get a circle. And this is a circle with a radius of 1. A more general equation for a circle is this guy right here, where I have h and k are the coordinates of my center point. So if I move h, I move the circle to the left or right. And if I move k, I move it up or down. And r is how big or small the radius is. Now, that's clearly not a function because, look at it, fails the vertical line test. And if I wanted to, if I really needed to take an equation like x squared plus y squared equals 1 and solve it in terms of y, I suppose I could. Wouldn't be that hard. But notice it gets harder if there's other things involved, like x minus 2 squared plus y minus 3 squared equals 1. Now what? How would I isolate this equation for y when this term here is going to give me a y squared and a y? I'm going to get a very convoluted formula. And it gets worse depending on what kinds of equations you're looking at. Going back to Desmos for just a minute, just some examples of other curves that we use a lot in the math and science world that aren't functions. Let me just hide my circles here. Here's one. This is, of course, an ellipse. It doesn't look like much of an ellipse right now. It looks like a circle because I have an a and a b of 1. But if I change the a and b values, you can see it gets more ellipsy. Right? We call that the eccentricity of the ellipse, how wide or how not circle it is. And so that's an ellipse, and very similar in formula is something we call a hyperbola. And what's special about those shapes, the circle, the ellipse, the parabola, and the hyperbola, is that they actually all come from a family of things called conics. We used to have an entire unit of conics in grade 12 math. There's a teacher that I'm kind of friends with online here that has her webpage. She has all kinds of gifts. She has to teach conics at her school. Come on, open you. Open, open. How do I make this open? Why won't you open? No, that's not making it open. I don't know what I'm doing wrong. Copy link to paragraph. No, I don't want to do any of those things. Why can't it just open? It is a hot link. It is a hyperlink. And, okay, I'm about to give up. This is just sadness. Okay, never mind. I will